Okay, now let's consider an example of a function which has a graph, and this is clearly an elliptical paraboloid with a vertex at the origin. And we're not looking for max and min, but of course the min would be at the origin, wouldn't it? And your second partials would both be positive. And actually, yeah, your second partials both be positive. Okay. We're not interested in that though. What we're interested in is the volume between the xy plane and the graph of this function above a rectangle down here in the xy plane. Now, you won't totally understand this picture, probably you won't totally understand it even after I do my best to point out what we've got here, but it's pretty clear that if this is your z-axis, here's your y, here's your x, and there's an arrow, there's an arrow, there's an arrow just to indicate the axes. Okay, this rectangle, well, that's right here. Okay, now I'm not even going to attempt to sketch this because I kind of picked a wrong rectangle. It'll be very difficult to sketch from the angle at which we're looking at this because the back is lower than the front and it's just going to be too hard to draw. But if we look at the graph of this function as it's cut by the plane of this line here, and this line is the line through x equals 3. Here's your origin, x equals 1, 2, 3. Okay. The x equals 3 line, and we take the plane parallel to the xz plane, well, we have a parabola in that plane. So there's a point on the parabola that's directly above here. There's a point in the parabola that's directly above here. So the part of that parabola that corresponds to this edge of our rectangle would just be this. A little higher over here than it is over here. And that's not drawn with any great accuracy, but that's kind of what it is. It would have a vertex directly above the x-axis, and the vertex would be at 3, 0, 9. So in the x equals 3 plane, our function z versus y, because x is being held constant, y changes, and z can change as we go up to the graph. We have z equals 3y squared plus 9 if x equals 3, because of course x equals 3, x squared is 9. If z equals f of xy, then z is 9 plus 3y squared. Okay? And that's what I've drawn here. Okay, so let's just kind of put a purple circle around this to indicate that the part of this parabola that lies above this edge of the rectangle is just this. Now, if we change the value of x, we change the value of x squared, but we still have 3y squared. So if we change the value of x, we go back to the x equals 1, then we're not going to have 9 here, we're going to have 1 squared, which is 1. What's that? That's a parabola, but it's lower. Okay, now I actually sketched that thing, and I guess I'll risk a little more color. Probably shouldn't have chosen green. It can be a little hard to distinguish from yellow. But above this line, well, the vertex lies just 1 unit above the line, because remember, on this line it's 3y squared plus 1, because x is 1. So it's lower, but other than that, it's geometrically similar to this, because we still have the 3y squared. 3y squared plus 9 means we just take the 3y squared graph and shift it up 9 units. There it is. 3y squared plus 1 would mean we take the same parabola and shift it up 1 unit, and we get this. So this would be what we might see in this point. So maybe I can kind of indicate that, but the lines and the shadings get pretty obscure. This one will be out front. and I'm probably obscuring everything there is to see about this, but you understand how this could be sketched, and you have an idea what it looks like. You also have an idea what this paraboloid looks like, this elliptical paraboloid, and what it would look like if we just cut a section out above this rectangle. Now, in the XZ direction, if we look at the parabola, piece of yellow chalk, above this line, we do a similar analysis, and it's going to look like something like this. Okay, and that's, of course, this face along this section of this line. Now, you put all that together into a picture. Well, it's a little tricky to draw, especially from this perspective, so I'm not even going to attempt it. But you get the idea that you have a shape up here. Okay, well, what we want to do is get a handle on the volume of the region between this rectangle and this shape up here, directly above the rectangle. So, we'll do that next.